does it mean to understand something or organize something in a way that reduces the complexity of the thing? There is no right answer to those questions, but having read a paper a second time, because first time was way too confusing, I think Jan and Carl express a tidy way of explaining organization and understanding in a nervous system through life. There is a lot of jargon in this paper, which took time for me to grasp, but I will try and explain things in plain language, hopefully, without oversimplifying the concepts too much. The main idea was to discuss the boundaries or Markov blankets of ideas and how those boundaries can help explain the interaction of our environment outside the boundary and our ideas inside the boundary. The thing inside the boundaries is a system from systems theory, but they are referred to as neuronal packets in this paper. If the systems or neuronal packets can maintain themselves through change over time, then we can perceive things using those systems. I imagine a circle in my head of the line representing the boundary, Markov blanket, the inside as the system or the neuronal packet, and the outside as the environment. Understanding is expressed as the composition and manipulation of the ensuing mental models, or neuronal packets, systems, capturing the relationship between objects. Understanding from a previous review was termed knowledge of dependencies, which in this explanation would be bits or objects inside the circle system being organized into chunks or clumps of objects through connections. The neuronal packets, systems, are created by organizing objects from our environment. So a phone system is built from parts in the environment, organized by a factory or a person. But a neuronal packet uses us to organize those parts, which are our generated mental models. The authors suggest this interaction between system and environment, brain and environment, as a process to help allocate resources, so our body's energy, to solve uncertainty, termed free energy in this idea, to maintain homeostasis or balance. In simple terms, to organize a mess, we use energy to maintain balance. The variation of free energy, or surprise of information, is used as something that fluctuates depending on the environment. This stems from the Bayesian brain hypothesis using beliefs to make and update predictions about what we should do in the future. What this means is that reducing free energy, or uncertainty, increases organization of information, therefore increases accuracy of future decisions and reduces its complexity. Reducing uncertainty relates to making things simpler. Sounds obvious when you say it like that. As I mentioned earlier, there is a lot of jargon, and for those interested in the research, understanding the jargon may help with future explorations. This is how I see it right now. A Markov blanket, as mentioned before, is a line or set of nodes that separates internal and external nodes or information. Neuronal packets are bounded subnetworks that have a physical assembly, so it isn't just a process. This suggests memories aren't circuit abstractions where the pulse darts all over the place in the brain, but are physical things with free energy supporting the boundaries, keeping them from being forgotten into the environment. Self-adaptive resource optimization uses the hypothesis combining neuronal resources to create neuronal packets and relies on thermodynamic energy efficiency. Is the system, or will the system, be wasting energy somewhere? If so, don't use the energy, don't organize the system. This implies self-organization as a system makes a decision if using the resource is a good choice or not. Basically, is it worth the energy to understand the thing? Folding, enfolding, and unfolding is the idea that connections can be made, broken, and changed between neurons or information, forming things like a Markov blanket or an organized system, neuronal packet. Virtual associative networks are essentially the strength of the connections as they hold themselves or connect themselves together. Increased weights and frequency of use of connections decrease the likelihood of entropy, the system dissolving back into the environment. In other words, rehearsal and repetition helps. Mental modeling is the deliberate action of grouping packets together for future use, like anticipation of something happening. The memories, neuronal packets grouped together, form posterior beliefs used in our predictions through the Bayesian processing. We learn and create mental models to store memories. Understanding, as mentioned earlier, is termed as using prior learning, mental models, to respond to unfamiliar situations. Negentropy generation is the creation of ideas, ideally in an effective way, avoiding too much energy expenditure. This is similar to the randomness as genesis principle from cognitive load theory, using read-around knowledge from the meta-ignorance research. Surface tension is the resistance of the system to dissolve back into the environment, formed by the free energy at the surface of the system, again, forming the boundary between system organization and environmental complexity. Cognitive efficiency suggests we use cognitive effort, or load, to generate understanding, trying to get a good ratio. The higher the ratio, the higher the efficiency, so less effort, high outcome is good. How we measure that effort or load is a conversation I will have in the future, so subscribe to the channel so you don't miss out on that one. Cognitive effort is the thermodynamic free energy used to create mental models, how hard you think to understand. Again, measuring that is for another video. In the paper, they asked 9 questions and responded to them using all of these terms, but they gave a summary which I think is much easier to relate to. In order to learn chess, you need to recognize the pieces, recognize the rules or constraints during the game, coordinate pieces and rule knowledge to make moves, create recognizable terms for situations like taking a piece, then developing memories of sequences of moves, using those memories to calculate good moves to win the game, and then the process to get better. That process is what they describe as learning, which understanding is a part of. They then explore different theories of understanding and apply the physics in the mind approach. All the systems, environment, Markov blanket stuff. Real technical term, that stuff. The understanding theories explored are all very similar. They first covered that an organism, us, doesn't sense information but engages with it. We volitionally choose to probe, manipulate, and create connections and models with the information sensed. Then there was emphasis put on simulation from internal effort. When sensing information, we create internal simulations by grouping mutors with effectors and grouping effectors with simulars, essentially saying that we make connections to reduce confusion. Free energy, so we can understand things due to reduced complexity because of the organization from connections. The authors go on to reinforce optimization and minimization of free energy to gain understanding, because it constrains prior beliefs for the predictions our brain will make in the future. Optimization making predictions easier and maybe more accurate. A quick point here, this reduction of complexity can be done poorly because we don't know what we don't know, so rational errors can be made at this point. If you're unfamiliar with the term, I will link a review up there. They round up explanations as maximizing the evidence used while minimizing complexity, accounting for a diversity of outcomes with the smallest number of explanations, essentially saying use scientific reasoning in your explanation. Co-instantaneous mental coordination is used to describe bringing thoughts together to solve a problem. And for finding a solution, recognizing the connections between those thoughts or the information is your understanding. Better recognition of the connections between information, deeper understanding, higher likelihood of solving the problem. Understanding was also described as enactive and embodied, meaning the models in our head allow us to not just recognize a basketball hoop as circular, a finger making a circular motion as circular, and a visualization of the circular thing as circular, but doing, acting, and creating a circular motion is also involved in cognition of mental models. I spoke about extended cognition before, which is in the same sort of ballpark. If you remember that circle thing I told you about regarding systems theory, well, in these figures, they use circles to illustrate what they've been discussing alongside other maths that go well over my head. But you can see in the black dots as elements, the grey circle as the system, the line as the barrier, and the white on the outside as the environment. This illustration has a lot going on, but if you think of each of those dots as elements in the big circle, but also a circle with dots in itself, you might see how parts build up a system, and multiple systems can become parts of another system. In the picture, some of the parts are moving systems, so out of a system, into the environment, then into a new system, which is the change in thinking or the learning process of the person. As in systems theory, these neuronal packets want to stay together, which requires energy and reorganization as time goes on. If you can, imagine this is not 2D, but 3D, so they're not circles, but sphere-like shapes dynamically moving in time as it moves forwards. This consistent adjustment of positions is proposed to be characters of cognitive processes, blobs getting bigger and smaller moving around. But despite all of this talk about making a choice, using effort, and simplifying elements to generate models of understanding, a neuronal packet or system can't be observed because the connections are not nicely put together in a sphere, they would be spanning all over the brain. So this theory needs to be inferred in terms of functional connectivity instead of just taking a picture. Neuronal bubbles or groups have been found in various brain studies in different parts of the brain. Some cited in this paper was the hippocampus of awake, free-moving animals, but combining analytical assessment and probabilistic inference only allows rough and quick assessment of the dynamics. They are testing measures of the math. Whether those results have anything to do with human understanding or intuition is up for debate. The notion that human intelligence is self-organized neuronal packets is a valid claim, going on to state that thinking can't happen without the ability to dwell on an object, switch between that and something else, and then return. Keeping all the objects intact while thinking alludes to the notion of working memory, being able to hold all of those objects in your mind while thinking. This paper goes on to suggest a metaphor of brain function including Bayesian and Aristotelian components such as predictive coding and active inferences between the system and its environment, continuing the use of this metaphor as the brain like a computer doing calculations to predict what might happen, to base decisions from. But for me, although this paper brings some clarity in how systems theory and Bayesian brain hypothesis can be connected, I'm left wondering how the energy or effort can be measured, how we could disprove the packets theory, and most interestingly to me, how our brain can do all that processing, decision making, etc. so quickly in some situations, which is where direct perception and the ecological dynamics approach piques my interest. But what do you think about this paper?